Welcome to Introduction to Confidence Intervals. So uh, we're going to focus here on the p-hat distribution. We can certainly do confidence intervals for other things. So here we're going to focus on estimating population proportion. So there are a few key, sorry about that. Focusing on estimating population proportion. There are a few key facts that we should keep in mind, which are sort of the basis behind our confidence intervals. So the first step is the normality of the p-hat distribution. So recall that if n times p and n times 1 minus p are both at least 10, so are both 10 or more, then the p-hat distribution is essentially normal. This is extremely important. All the stuff we have been looking at with probability, etc., is based off of normal distribution. Next up, the mean and standard deviation of the p-hat distribution. We know what these are supposed to be if we know the actual or true population proportion, as well as our sample size. So the mean was mu sub p-hat. The mean of our p-hats is just the true population proportion. And our standard deviation, or otherwise known as the standard error, was equal to the square root of p times 1 minus p divided by n. So again, recall, as long as that we had that sort of large enough condition for the p-hat distribution to be normal, we also know what the mean and standard deviation should be, just knowing the true population proportion and the sample size. The other key piece of information we're going to use here is, for now, we're going to focus on that 95. So focusing specifically on the 95 of our 68, 95, 99.7 rule. We have that 95% of the data in a normal distribution, or the data from a normal distribution, falls within 2 standard deviations of the mean. So from here, we're going to put these 3 pieces of information together. So putting these facts together, we have our p-hat distribution is normal. We have that the mean is at just p, the population proportion. And what we also have is, because this is a normal distribution, if we go out by 2 standard deviations to both sides, then we have that 95% of the data, or in other words, 95% of the samples, have p-hat in this stretch. So 95% of samples have a p hat within 2 copies of sigma sub p hat from the mean. So from the true population proportion. Now, when we refer to distance, the distance it takes, or the distance from me to say my front door, is exactly the same as the distance from my front door to me. So when we refer to distance, it doesn't matter which one we're starting with. So if, say, we pick a value on our number line that is within 2 copies of sigma sum p hat from P, it is also true that P is within 2 copies of sigma sub p hat from that particular value. So sort of reversing the way that we describe the or measure distance. So reversing the direction we are measuring distance. We could also say that 95% of samples are such that P, the true population proportion, or let's actually just write that out, such that the true population proportion is within 2 copies of sigma sub p hat from p hat. Or in other words, for 95% of samples, if we look at our number line and place p hat, and then we go up to the side by 2 copies of sigma sub p hat, for 95% of samples, P will fall within the interval created around that. There's that sample's P hat. So for 95% of samples, its corresponding interval, which will be p hat minus 2 copies of sigma sub p hat to p hat plus 2 copies of sigma sub p hat, will contain the true population proportion. So we call this a 95% confidence interval, because for 95% of the samples that we could pick, whatever interval we come up with will contain the 95% of the time, our sample's corresponding interval will contain the true population proportion. So hence the 95% confidence interval. Because 95% of the time, our method of running this statistical study will produce a result that contains the true population proportion. Right, so this is, again, the basics behind confidence interval. We will go ahead and do an example in the next video.